Gila is a Marvel comic book character who is a 7-foot-tall goddess with superhuman strength. She's immune to fire, radiation, toxins, death, and aging. The sci-fi Gila was inspired by the ancient Norse goddess of death, who has withstood many of the same challenges as the real-life heroine, the immortal Henrietta Lacks. The immortal Henrietta Lacks, Gila, grew up a poor black tobacco farmer whose cells were taken without her knowledge in 1951, which led to her involuntarily being directly responsible for many of the most important turning points in medical history. Henrietta Lacks' cells were the first immortal human cells grown in culture, and are still alive today, though she has been dead for more than 60 years. One scientist estimates that if you could pile all Gila cells ever grown into a scale, they would weigh as much as 100 Empire State Buildings, which is incredible considering that an individual cell weighs almost nothing. In 1951, a poor black woman named Henrietta Lacks died from cervical cancer, but pieces of the tumor that killed her were taken without her knowledge or consent and continued to live on. Not long before her death, Henrietta Lacks lived a simple life in Turner Station, a small, segregated Baltimore community where she moved in 1943. She had come by train from a plantation town in Virginia. Henrietta knew she was heading into a more modern world. What she did not know was that less than 8 years later, her cells would give rise to breakthrough research in medicine. On February 1st, 1951, Howard Jones, a Johns Hopkins physician, found a smooth, eggplant-colored tumor on Henrietta's cervix. Jones carefully cut a section of her quarter-sized tumor and sent it to the lab for a diagnosis. The tumor was malignant. Henrietta returned to Johns Hopkins 8 days later. Physicians used radium in an attempt to kill the cancer. But before applying the first treatment, a young resident took one more sample. This one went to George Guy, head of tissue culture research at Johns Hopkins Hospital. He and his wife, Margaret, had been searching for human cells that would live indefinitely outside the body in order to do their cancer research. After 2 decades of failure in their laboratory attempts, George Guy got his hands on Henrietta Lacks' cells and everything changed for medicine. At that time, the cell line was said to be named after a Helen Lane or Helen Larson in order to preserve Henrietta's anonymity. Henrietta's cells multiplied like nothing anyone had ever seen. They latched onto the sides of test tubes, consumed the medium around them, and within days, the thin film of the cells grew thicker and thicker. At the same time, Henrietta's tumor cells took over her body as quickly as they had taken over the test tubes, and she died. On the day she died, October 4th, 1951, George Guy appeared on national television with a vial of her cells.
I will show you some actual pictures of colonies in a test tube of cancer cells such as those I just showed you. It is quite possible that from fundamental studies such as these, that we will be able to learn a way by which cancer can be completely wiped out.
Dr. Guy introduced the nation to his hopes for curing cancer, while Henrietta's family knew nothing about her revolutionary cells. Henrietta's body was laid to rest in an unmarked grave next to her mother in her hometown of Clover, Virginia. Guy and his colleagues went on to develop a test using Gila cells to distinguish between the many polio strains. Henrietta's cells made it possible to isolate the strain that produced polio's crippling effects. This information enabled Dr. Jonas Salk to create a vaccine, and the National Foundation for Infantile Paralysis established facilities for mass-producing the Gila cells. Despite being cancerous, Gila still shared many basic characteristics with normal cells. The fact that they were malignant just made them more useful. They grew much faster than normal cells, and therefore produced results faster. Gila was a workhorse. It was hardy, inexpensive, and everywhere. Guy shared Gila cells with other researchers simply for the benefit of science, not for financial compensation. It started as just a few Gila cells in a single lab, which led to giant factories that were mass-producing polio vaccines. The cells from this one tumor became a foundation of modern science, which led to breakthroughs in many medical discoveries. When we hear the word clone, we imagine scientists creating entire living animals, like Dolly, the famous cloned sheep, using DNA from one parent. But before the cloning of whole animals, there was the cloning of individual cells, Henriettas cells. In 1953, a geneticist accidentally mixed the wrong liquid with HeLa and a few other cells, and it turned out to be a fortunate mistake. The chromosomes inside the cells swelled and spread out, and for the first time, scientists could see each of them clearly. That accidental discovery was the first of several developments that allowed researchers to discover that normal human cells have 46 chromosomes. This discovery made it possible to diagnose genetic diseases. As the Cold War escalated, some scientists exposed HeLa cells to massive doses of radiation to study how nuclear bombs destroyed cells and to find ways to reverse that damage. HeLa cells went up in the second satellite ever in orbit, which was launched by the Russian space program in 1960, and almost immediately afterwards, NASA sent several vials of HeLa into space in the Discoverer 18 satellite. When the first humans went into orbit, HeLa cells went with them, so researchers could study the effects of space travel and zero gravity on human cells. Scientists in labs throughout North America and Europe began fusing cells and using them to map genetic traits to specific chromosomes, creating a precursor to the human genome map we have today. Cosmetic and pharmaceutical companies throughout the United States and Europe began using HeLa cells instead of laboratory animals to test whether new products and drugs caused cellular damage. In 1975, 24 years after Henrietta's death, her family discovered that her cells had been alive since her death and were the standard reference cells that nearly every molecular scientist around the world had been working with. Yet her family could not afford health insurance to pay for drugs their mother's cells probably helped to create.
Well, it leaves me feeling kind of not angry a little bit that I don't have the medical coverage, and then that my mother's cells being used all over the world for science purpose, and then the medical coverage that we have is zero, me and my brother.
In the 1950s, it was not at all uncommon for physicians to conduct research on patients without their knowledge or consent. Since the era when Henrietta walked through the doors of Hopkins, the field of biomedical ethics was born, and with it came regulations about informed consent. Then as now, there was no requirement to inform a patient or their relatives about such matters because the discarded material or material obtained during surgery, diagnosis, or therapy was the property of the physician and/or medical institution. This issue and Henrietta's situation was brought up in the Supreme Court of California's case of Moore v. Regents of the University of California. The court ruled that a person's discarded tissue and cells are not their property and can be commercialized. HeLa cells are termed immortal in that they can divide an unlimited number of times in a laboratory cell culture plate. The chromosomes in HeLa don't shorten as cells divide. Most cells can divide only a certain number of times because their chromosomes shrink with each duplication. But HeLa has an active enzyme that keeps the chromosome ends from shortening.
You actually benefited from their mother's death. Every single person out there isn't a single person in the world really who hasn't benefited in some way from these cells. I've had kids come up to me saying, my mom had cancer when I was growing up and she's alive because she took this drug that they used HeLa cells to develop.
In 2010, a former fellow of Dr. Guy gave the money to fund a grave marker for Henrietta Lacks. The marker reads in part, "In loving memory of a phenomenal woman, wife, and mother, who touched the lives of many. Here lies Henrietta Lacks, HeLa. Her immortal cells will continue to help mankind forever."
Think about it, it just makes me feel good that my mother has contributed so much, and it's being known that Henrietta Lacks is still living today.
Henrietta Lacks's involuntary contributions to medical advancements were directly responsible for a significant and everlasting turning point in history.